Right now, you are standing in a city during a total blackout. Not a small town, but a sprawling, continent-spanning metropolis. 90% of its lights are suddenly dead, and from your window, you can only see the few, dim streetlights on your own block. What if our universe is exactly the same? For decades, we looked out into the cosmic night and counted the lights. We saw glittering cities of stars, vast collections we call galaxies. We tallied them up, one by one, using our most powerful telescopes. Our best estimate, the number that has been in textbooks for a generation, was that our observable universe contained roughly 120 billion of these galaxies. A staggering number, yes. But it was a number we felt we understood. We thought we were seeing the full extent of the city. We were wrong. We were not just wrong, we were off by a factor of 10. The latest analysis, a painstaking cosmic census, has revealed a shocking truth. The universe is not a city of 100 billion lights. It is a metropolis of at least 2 trillion. 2,000 billion galaxies. And that means that for all of human history, for all our powerful instruments, we have been completely blind to 90% of the cosmic population. We are standing in a city of 2 trillion lights, yet we can only see 1 in 10. So where are they? Where is this ghost universe hiding? And if we have been missing 90% of the galaxies, what else are we missing? To understand how we missed something so enormous, we have to rewind the clock. Back to a time when the universe was not a city of lights at all. It was just one. For a very long time, we believed that the entire universe consisted of our galaxy alone. The Milky Way. We saw fuzzy patches in the sky, spiral nebulae, but they were assumed to be part of our own cosmic home, perhaps new solar systems being born. The universe was small, knowable, and we were at the center of it. This comfortable illusion was shattered in the year 1924. An astronomer named Edwin Hubble, using the most powerful telescope of his day, pointed his instrument at one of these spiral nebulae. He was hunting for a specific type of star, a variable star, which brightens and dims with a precise rhythm. He found several. These stars are special. They are cosmic measuring sticks. By timing their rhythm, Hubble could calculate their true brightness, and by comparing that to how dim they appeared, he could calculate their distance. The answer he found broke reality. These stars, and the nebula that held them, were far too distant to belong to our Milky Way. They were hundreds of thousands, even millions of light-years away. They were not gas clouds. They were entire other galaxies, island universes floating in an abyss, far outside our own. In that moment, the universe expanded. It went from a single, cozy home to a vast, dark ocean dotted with countless other islands. And immediately, the most human of questions arose: how many? Something incredible is happening in the comments. Last week, a user named Starlight Seeker asked if the Great Attractor could just be a massive collection of these hidden galaxies. What's your theory about this missing 90%? Drop it below. I read every comment, and the best ones might just spark the idea for the next video. And if you love cosmic mysteries, if you feel that pull of the unknown, hit subscribe. Because what comes next will shake everything you thought you knew about your place in the cosmos. Since Edwin Hubble's discovery, astronomers have been locked in a cosmic quest to find out just how many galaxies there are in the observable universe. But this is like trying to count every person on Earth, at night, from a satellite. You can only count the ones who have their lights on. For decades, we just kept building bigger telescopes, trying to see fainter lights. The real revolution came in 1995. Astronomers pointed the Hubble Space Telescope at a patch of sky that looked completely, utterly empty. A tiny speck of darkness near the Big Dipper, no bigger than a grain of sand held at arm's length. They left the telescope's eye open for over 100 hours, letting the faintest, most ancient photons of light trickle in, one by one. What they saw changed astronomy forever. It was the Hubble Deep Field. That tiny, empty patch of sky was not empty at all. It was overflowing. The image revealed hundreds upon hundreds of galaxies that had never been seen before. Spirals, ellipticals, strange, distorted young galaxies from the dawn of time. This was the first real deep look into the universe. It was like looking at a single drop of ocean water under a microscope and finding it teeming with life. Astronomers were stunned. If this one tiny grain of sand in the sky held this many galaxies, how many must the whole sky hold? Additional deep observations with Hubble and other instruments followed, each one pushing deeper, finding even fainter and more distant galaxies. They did the math. They extrapolated from that one tiny patch to the entire celestial sphere. The number they landed on was 120 billion. For over 20 years, this was our map of the universe. This was the city we lived in. But even as we celebrated this number, there was a quiet, nagging problem. A paradox. If the universe is infinite, or even just as big as we think it is, and filled with that many stars and galaxies, why is the night sky dark? Shouldn't we be bathed in an eternal, blinding light from every direction? This is known as Olber's paradox. The textbook answer was always that the universe is expanding. The light from the most distant galaxies is stretched out, redshifted into invisibility, and the universe is not infinitely old, so the light from the most distant objects simply has not had time to reach us. By the way, the cosmic BO community is incredible. People here ask questions that challenge even scientists. Last week's debate about whether we live in a simulation got so deep, I almost had to check my own code. Jump in. Share your thoughts. We are all trying to figure this out together. Now, here's where things get truly strange. That answer about the expanding universe was true. But it was incomplete. The darkness of the night sky was hiding a secret, and the key was in that 120 billion number. It felt wrong to some astronomers. The models of galaxy formation, the computer simulations of how the universe grew, they all predicted more. This brings us to the new analysis. A team of astronomers decided to count again. But this time, they didn't just count the lights they could see. They combined all the deep field images from Hubble and other telescopes with new mathematical models. They essentially calculated how many galaxies must exist that are too faint, too small, or too far away for even Hubble to detect. They were searching for the lights that were out. Their conclusion was a bombshell. The previous estimate of the number of galaxies within the observable universe is at least 10 times too low. That number, 120 billion, is not the total population. It is merely the brightest 10%. The observable universe, our cosmic horizon, must contain 2 trillion galaxies. This means that for every galaxy we can see, there are 9 others lurking in the darkness, existing as ghosts in our telescopes, their light too faint for our current technology to capture. We are not just missing a few small towns on the edge of the map. We have missed the entire suburban sprawl. We have missed 90% of reality. But if they exist, where did they go? And if they are truly there, what does this invisible, ghost universe tell us about our own past and our ultimate future? We thought we had a map of the universe. It turns out, we were only looking at the brightest 10%. We have missed 90% of reality. So, where did this ghost universe go? How can 2 trillion galaxies simply hide? The answer is not that they vanished. The answer is that they were stolen. They were consumed. And to understand this, we have to become cosmic archaeologists. We have to dig into the deepest layers of time. This new, shocking analysis did not just rely on what Hubble can see now. It allowed astronomers to look back in time. More than 13 billion years into the past, to the earliest days of the universe. This is the cosmic dawn, the time just after the first stars and galaxies ignited. And when they peered into that ancient epoch, they found the missing 90%. In the early universe, the density of galaxies was staggering. It was 10 times higher than it is today. Imagine the universe not as a vast, dark city with scattered lights, but as a single, sprawling, blindingly bright nursery. It was packed with newborn galaxies, all shining at once. But these were not the giants like our Milky Way or Andromeda. Most of these galaxies were relatively small and faint. They had masses similar to the satellite galaxies that surround our own Milky Way today, like the Magellanic Clouds. They were not yet grand cities of stars. They were more like tiny cosmic villages and hamlets, trillions of them, all clustered together in the primordial darkness. So, the mystery deepens. If there were more galaxies back then, where did they all go? Why is the universe less crowded today? This is where the story truly unfolds. These findings are powerful evidence for one of the most violent processes in the cosmos, galaxy evolution. Galaxies, it turns out, are cannibals. Imagine the early universe as a landscape filled with trillions of tiny, independent streams. Over billions of years, gravity began to pull these streams together. Small streams merged to form larger creeks. Creeks flowed into rivers. And rivers collided to form the vast, mighty oceans of stars we call spiral galaxies. Those 2 trillion small, faint galaxies did not disappear. They were the building blocks. They were the raw material. They were devoured by each other, merging and colliding over 13 billion years of cosmic history. This process of constant merging dramatically reduced their total number over time. The ghost universe of 2 trillion is our own ancestry. The Milky Way is not a single, pristine creation. It is a Frankenstein's monster, stitched together from the corpses of hundreds, perhaps thousands, of smaller galaxies it has eaten over its long life. If your mind is blown right now, tap that like button. It's a simple click, but it helps the algorithm show this revelation to more curious minds. And trust me, we are just beginning to understand what this means. What I am about to reveal next changes not just the past, but the future. So, this explains the past. But where is the missing 90% today? They are still here. They are the leftovers. They are the survivors. The 2 trillion number includes the ghosts that are still out there, the ones that failed to merge. They are the tiny, faint, satellite galaxies that still orbit the giants, like moths around a flame. Our own Milky Way is surrounded by a swarm of them. And more importantly, they are the galaxies that are simply too far away. Their light has traveled for so long, across such vast stretches of expanding space, that it has become too faint and too stretched for our current generation of telescopes to see. Astronomers can only infer their existence based on models and calculations. They are mathematical ghosts, haunting our data. They are the dark part of the cosmic census. This gives us a profound new answer to that old question: why is the night sky dark? It is not dark because it is empty. It is dark because it is full of lights we cannot see. The sky above you, that blackness between the stars, is not an empty void. It is a graveyard of ancient galaxies that have been consumed. And it is a phantom ocean, teeming with 2 trillion other galaxies whose light is just a whisper, too faint for our human eyes to hear. This changes our entire perspective. We thought we were counting the population of the city, but we were only counting the skyscrapers. We missed every house, every apartment building, every single small business. This raises an even more profound, and perhaps unsettling, question. We have been staring at the universe for our entire existence and we missed 90% of the biggest, most obvious structures in it. We missed 2 trillion galaxies. If we could be this wrong about something so enormous, what else are we wrong about? What other ghosts are lurking in our data, hidden just beyond the reach of our understanding? We have been wrong. Staggeringly wrong. For every single galaxy we can see, 9 others are hiding in the dark. We have missed 90% of the cosmos. This is not just a rounding error in an astronomer's notebook. This is a profound statement about our own perception. It is a lesson in humility, delivered from the depths of space. We are staring directly at reality, and yet we are fundamentally blind to almost all of it. So, what does this mean for us? Why does it matter if the number is 120 billion or 2 trillion? It matters because this is not an abstract counting exercise. This is a search for our own origin story. We now understand that our Milky Way galaxy is a cannibal. It is a vast structure built from the wreckage of the very ghosts we are trying to find. The atoms in your body, the iron in your blood, the calcium in your bones, these elements were forged in stars, yes, but those stars likely belong to other galaxies, smaller ones, that our Milky Way devoured billions of years ago. We are the children of a 2 trillion galaxy universe. To know ourselves, to understand how our own home was built, we must find the remnants of our ancestors. We are cosmic archaeologists, trying to excavate the ruins of the galaxies that died to give us life. But how do you find a ghost? How do you see a galaxy that is too faint, too small, and too far away to be seen? For this, we needed more than just a bigger mirror. We needed a different kind of eye. The Hubble Space Telescope, the instrument that gave us the deep fields, sees the universe primarily in visible light, the same light our eyes see. It showed us the brilliant 10%. But to find the missing 90%, we had to build a time machine. That time machine is the James Webb Space Telescope. This new observatory is not just a successor to Hubble. It is a completely different kind of instrument. The James Webb Space Telescope is a ghost-seeing machine. It is designed to capture the one thing that these ancient, distant, missing galaxies betray their presence with: heat. As the light from these very first galaxies travels for over 13 billion years to reach us, the expansion of the universe itself stretches it. It is like the siren of an ambulance moving away from you, its sound stretching to a lower pitch. This light is stretched so profoundly that it shifts from visible light, which Hubble sees, into infrared light. It becomes a faint, cosmic echo of heat. The James Webb Space Telescope, with its enormous golden mirror, is a high-tech infrared eye. It is blind to much of the light Hubble sees, but it can see this ancient, stretched, whisper-faint heat from the dawn of time. It is the perfect tool for cosmic archaeology. It is, right now, peering into the dark, past the brilliant lights of the nearby city, and finding the faint, flickering embers of the 2 trillion hidden villages. It is finding our ancestors. What we've uncovered today, this missing 90% of the universe, is just one piece of a much bigger puzzle. We are realizing that our map of reality has vast, dark, unexplored continents. Next week on Cosmic BO, I am releasing something extraordinary. A video about a mystery much closer to home. A force that is pulling our entire galaxy, and 100,000 others, toward a single point we cannot see. It is called the Great Attractor. And the findings? They will rewrite everything you think you know about gravity. Hit that notification bell right now. Because the universe still has secrets to reveal. And you won't want to miss what is coming. What will the James Webb Space Telescope find in that darkness? It is already finding them. It is pushing back the frontier, revealing galaxies that are older, smaller, and stranger than our theories ever predicted. It is confirming that the early universe was indeed that chaotic, crowded nursery of 2 trillion streams. We are, for the first time, watching the rivers form. We are witnessing the first acts of cosmic cannibalism. We are not just looking at history, we are watching the first chapter of our own origin story being written. This new understanding changes our place in the universe. We are not an island in a vast, empty ocean. We are a wave that is part of a much larger, turbulent sea. We are the sum total of countless collisions, a structure built from the ghosts of a universe that was 10 times more crowded and violent than we ever imagined. We are not just observers of the cosmos. We are its participants. We are its memory. We are the living, breathing evidence that those 2 trillion galaxies existed. This is the mind-bending truth. We thought we were in a city of 100 billion lights, but we were wrong. We are in a city of 2 trillion. And the reason the night sky seems dark is not because it is empty, but because our eyes are not yet strong enough to see the ghosts that are everywhere. So here is my final question for you. If we have been blind to 90% of the largest structures in the universe for our entire history, what other fundamental truth about reality might we be completely wrong about, right now? Drop your answer in the comments. I cannot wait to see what you think. And if you love this deep dive into the hidden cosmos, check out my video about the Boötes Void. It explores the opposite mystery, not what is there, but what is missing, from a completely different angle. The link is in the description, or click the card right now. This is Cosmic BO. Until next time, keep looking up.